Hi folks, the next few lessons here we're going to go through just some introductory stuff and talk about kind of the nature of physics, the nature of science, and that sort of thing. So let's jump into it. So first we're going to talk about the nature of science. This is probably review for most of you, but for those that it isn't, I do want to make sure we're on the same page with some of these concepts. First, the definition of science here that I'm going to use for our class is how we try to understand the world around us. So that's the definition of science that we're going to use. So science is what helps us understand the world around us. Now, why would we want to understand the world around us? Again, so we're on the same page. The three things that I came up with were to appreciate the natural beauty, like the world and the universe is incredible. And so I want us to be able to appreciate that. And by better understanding it, we can better appreciate that beauty. More practically, it lets us make predictions before something happens, which can be useful if you want to know if, say, your bridge is going to collapse. It's good to be able to predict that rather than just have to build it and see what happens. And then it also lets us solve problems that do come up. So if you start building your bridge and you realize it will collapse, what can you do to keep it from collapsing? And so when we talk about this idea of good science, like what makes science, like what is good science, it's anything that helps us do the stuff up here. Conversely, bad science is what makes those things harder. So notice that and you'll see this in the next slide here, we're straying away from necessarily the complete 100% accuracy, but more about these ideas of what helps us do the things that we're going to use it for. And that's because science can't ultimately determine whether something is true or not. That's a philosophical question, that's not a scientific one. Science does pursue truth, and it can help us be very confident in what we believe about something and be pretty sure that this is probably true. But in the end, it's just has this repeated out to the degree that we're 99 point hundreds of nines % sure, but there's no way to ultimately determine using science whether something is true or not. And so that leads us into the scientific progression. You've probably seen this before. You go from hypothesis into theory into law. So a hypothesis is a testable prediction. Key thing I want to point out is testable. A hypothesis has to be testable, meaning you can't say something like, I think there are ghosts, but you can't interact with them or measure them or see them or figure out if they're there in any way. That's not a hypothesis because it's not testable. It may be a thought you have or an idea or a speculation or a guess, but it's not a hypothesis because it's not testable. A theory is a rigorously studied hypothesis that still holds true. So if we run a bunch of tests on this hypothesis and we find that it continues to be true, it can graduate to theory. So this is hundreds of tests, thousands of tests, lots of different people, lots of different conditions. It's not just a few tests in your garage. And then lastly, we've got a law, which is a rigorously studied theory that can be proven true for all circumstances. And I've put this little asterisk here on all because some laws only apply to specific circumstances. And actually, most of the laws that we'll talk about in this class are technically in this category, where it applies for anything on Earth that's not moving very quickly, or that's not super tiny, or that's not super gigantic. So it applies to everyday objects, but maybe not to some of these edge cases. On occasion, theories may be adjusted, and on exceedingly rare occasions, a scientific law may be adjusted. but this is only when there's irrefutable evidence that our fundamental understandings of the world or of the universe are inaccurate. So if someone's saying like, oh, I've proven that Einstein's theory of relativity is wrong, that's probably not the case. If it does turn out to be the case, then that means that we're going to have to fundamentally reshape how we understand the world. So in other words, theories and laws should generally be considered true because as far as we know, they've proven true for 100 years, hundreds of years. Everything that we've done builds on this, so therefore it's probably true. Or there's something that's completely different that we don't understand, that we have no idea about at this point. So, what is physics? Physics is the study of how the universe behaves and has two major subdivisions. We've got classical physics, which is basically everything that we've studied in physics up to the early 1900s, and then modern physics, which is everything that's come kind of after that. In classical physics, you can kind of divide that into mechanics, electricity and magnetism, fluids and thermodynamics. You don't really need to know much about these other than the fact that mechanics is what we'll study in this class here. For modern physics, we've got quantum mechanics, particle physics, and relativity. And at some point, we'll probably touch on a bunch of these other topics, but the main thing for study, like I said, is that mechanics.